We're here at Micronics today. They've designed these SLS printers that are going to really change the way people look at the cost and value proposition of printing with powder-based materials. I thought it was going to be like 100 people, but it's just Luke and Henry here that are running the whole operation.
Hi everyone.
Sponsor JLC 3DP.
So I want to take a look at like everything you've got going on in here because there's so many cool machines. So let's go check everything out.
Yeah, so we have our print graveyard, and this is all the prints we've done over the past 2 years. We also have some prototypes, starting with our first gen to the last gen before our product launch. In here we have our machine shop, CNCs, a lathe, laser cutter, water cutter, 3D printers, a lot of prototyping tools. It allows us to iterate quickly. Our snack shelf, he's guarding the snacks. And over here we have our print farm. We got one printing right now. For the two of us, we have 3 offices here. This first one is my office. This is where I do most of the programming and dev work on the front-end software.
Here's my room. Here's where all the electronic magic happens.
Yeah, I like how you're like doing a lot of analog and digital stuff there.
Yep.
Very complex electrical work. I got to ask about this. What is this doing in an office space? This isn't normally what you see.
Well, saves me a 20-minute commute every day. Our goal here at Micronics is to democratize advanced technologies. We see a lot of things that are currently way more expensive and just out of reach, and we just want to bring that to more people. So SLS is one of the things that we looked at. We thought that it's something that we are able to reasonably bring to a consumer market, and that's what we are starting with.
Well, let's take a look at some of the prototypes you've got here because it really kind of demonstrates how you've advanced from, you know, like a basic idea into the product that you have now. All right, so I like to call this the hallway of history. It kind of, you know, goes through the evolution of your product here. Luke, what can you tell me about this machine? You know, it looks like a very basic prototype / primitive SLS machine.
So when we first started, we had a lot of ambitions, but we knew we had to take the first step, which was getting a layer of powder down uniformly. And so that's what we demonstrated with this machine, along with some, you know, getting familiar with machine control.
I like to call this the Ender 3 of SLS machines. It's just like kind of stuck together.
This was our second prototype. It was the first one that actually sintered nylon, and we got a very loosely sintered benchy out of this guy. So this one, the main improvement here was the form factor of our build chamber. So we added a glass plate to enclose the print area, and so that gave us huge advantages with thermal control.
Having the glass there probably helps keep the powder contained in the unit too, right?
Right, yeah, it keeps in the powder and it keeps in the heat.
It looks like you've really sorted out your user interface by this point.
A lot of machines will have a color touch screen, but for our purpose, it doesn't add much functionality. So we decided to just keep it simple. 3 capacitive touch buttons and a monochrome OLED. And you could see where we started very ambitious with an integrated depowdering system. But as we used these machines ourselves, we really started focusing in on what improves the actual experience of using the printer and what can we remove.
Okay, so here's where all the magic happens, or maybe not all the magic, but at least the part where, you know, printers are printing stuff, which I think is magical.
Yeah, this is the most exciting part of the building, I would say. We have 9 machines in here right now, and we've been running them constantly.
I actually was wondering this when we were looking at your prototypes, but like, what are you going to do with those? Because I'm sure a lot of people in the comments would be like, just please send it to me. I don't care if it's not perfect. I just want to use it.
Yeah, well, we want to use the non-perfect printers too. So the goal is to break the printers so we know how they break, we can fix them, and maybe address issues.
Are any of them actively printing right now?
We usually start our prints for our print farm overnight, but if you want, we can start a print right now. What would you like to print?
I think I'm going to go with a benchy.
We've got a benchy for you.
Okay.
So we can pull one of these into the slicer, and I'll turn it over to you at this point.
Okay.
A basic rundown on the controls. If you want more than one benchy, you can hit the arrows and hold shift to duplicate it.
Okay. Hit the arrows.
So it's just an instant duplication. Arranging these might be a pain, but a good approximation of what the best packing is actually a physics simulation with gravity. And so now we're in a physics mode, and you can actually interact with the models.
Okay, so I can just click them and toss them around.
And you can even grab them and throw them out of the build volume.
Okay, let's get rid of that guy. We only need 3 benchies.
But they're going to respawn. Don't worry,
no.
you won't lose them.
But I guess one of the advantages of an SLS printer is that its print time is determined by layer height or height of your printed object.
Right. It's similar to SLA in the fact that it's not, you know, exactly what you have in the layers, it's how many layers is one of the biggest determinants of the time.
So like I have 2 benchies loaded up right now, but if I could stack like 8 on that first like little area, that'd take approximately the same time?
It'd be a little longer, but around the same time. And another advantage, it allows you to print multiple things in 3 dimensions. So you're unlocking a build volume rather than fitting things into a build area. So we'll slice this file and we'll put it on an SD card and then we'll get it over to the printer.
So what do I do with this SD card now that we're ready to print?
Well, there's a purpose-made slot for the SD card right here on the side. Just pop the SD card in.
All right, you know, I'm used to on my 3D printers, you have to put it in upside down, but I like that you got this right side around. I guess I need to load some filament or I guess powder here.
Yeah, our print material. So right now there's nothing in our printer. So we'll go ahead and grab a chamber from over here. So go ahead and you can line it up so that these guiding bolts are on the rails here. Clicked in place, you're all good to go. So you can close it up.
Oh.
And then if you'd like to select
let me redo the door close. That was a little... So we're gonna print a benchy out. It says 1 hour and 42 minutes. So this machine was already loaded up with powder when I got to it. But I'm kind of curious what the material looks like before you get it loaded up in here.
Sure. Yeah, so the material is a powdered nylon. It comes in this container. It's a 50 micron particle size, so it flows really easily with our recoder.
So how does that compare to like a normal powder, like, I don't know, like flour or something?
It flows and actually looks a lot like powder, minus the fact that it's a dark gray color. It's a fully self-contained powder system, so we're trying to minimize the risk of powder escaping the printer and getting over your workspace.
Yeah, and I don't see a whole lot of dust around here, so you know, something must be going right.
Yeah.
What are the things that you're learning about your machines through running them every day?
Things that we've been focused on since the beginning, which is the thermal uniformity, the heat control, and we're kind of perfecting a material profile so that the printer prints reliably no matter the geometry.
I struggle with figuring out what I want to print on my machines. But when you got this many, I imagine it's more challenging.
Right. Yeah, well, the great thing is we don't decide what we print. We actually have a print service that we offer. So people will send us their models. There's an instant online tool. We'll generate a quote, and then you can pay for the parts, check out, and then we'll have them printed and shipped within 3 to 5 days.
Oh, cool.
It's a good way to not only test our machines, but give future customers an example of what a part printed on our machine might look like.
Compared to FDM or SLA, is it kind of better or worse or like in between?
It's in between in the detail. So it'll give you better detail than FDM, but not quite as fine details as SLA. SLS is a medium resolution, high accuracy technology. And some of the parts we can print are parts that can only be printed with SLS, and the main advantage is there's no supports. So the surface finish is really nice.
Okay, so we've got a pile of parts here, so let's check out the print
Yeah.
quality.
Here's an example of a larger part that we've printed, and one thing to note is that these wingtips needed no support while printing.
Yeah, this would be very difficult to print on an FDM or SLA printer just because you'd have to run up like supports up to it. And it feels pretty sturdy too. Is this a solid part?
Correct, so it is 100% dense.
Okay.
Here's a good example of a structural part. This is actually a quadcopter frame, and so this design specifically is really difficult to print with any other technology. This organic lattice shape.
Yeah, this looks like topology optimization. A lot of computational stuff went into this. This would be hard to model, but easy to print at least.
Right, easy to print. Another advantage of these frames printed in SLS is that SLS doesn't have any difference in strength between the print orientations. So it's an isotropic part. It's strong equally in all directions. Here's another good example of the fine details that we can achieve on our printer.
That's another benchy.
It's another benchy, but this one has a Voronoi lattice on it, and again, printed with no supports. Very difficult to print any other way.
I noticed one over here actually that I want to take a look at. This one's the cauliflower, I think. How did it perform on this calibration print?
It printed within 0.2 millimeters.
So do you have to deal with like, after you print it, it's kind of a higher temperature and then you take it out and it shrinks a little bit? Is there like some kind of compensation you have to do for that?
Yes, so when you're taking the powder and you sinter it, it increases its density. So we do some compensations in the X, Y, and Z to make sure that the parts you slice come out the same dimension as the model. Here's an example of a minifigure that we've printed. And the great thing again with SLS is you can print a ton of those in a single print.
You can basically mass produce these.
Right, and there's no need for supports, so there's no real cleanup of the support areas afterwards, which is another huge thing that I know takes a lot of time with other printing methods.
Yeah, not just printing methods. Like if you were to injection mold something like this, I imagine the mold would be super complicated. You don't have to worry about that as much when you're designing and building these things.
The demonstration here is how well the surface takes paint. So this is just a regular nail polish.
There's another one here that I squeezed earlier. And this one feels kind of squishy, like a rubbery material.
Yeah, so that's a window into the future. So one of our materials that we'll support in the future is TPU.
I print out a lot of these. This is a good test print for my FDM machines. And usually up here I get a little bit of issues with the overhangs when they get super steep. But there's virtually no difference between like a vertical wall and a completely overhanging wall here. Oh, it's printed like this? Oh, okay. No matter what, this is going to be challenging to print. But
unless you have an SLS machine.
Right. And then like this is a good example of just an electronics enclosure. This is the kind of stuff that people that are hobbyists or makers like to make for their own little inventions and stuff.
Yeah.
Okay, so we've got like some really cool articulated models here. This is a latch? Holy cow, that's a whole latching mechanism. This looks like some sort of watch chain. And then you've got this kind of dual gear spinning thing with two helical gears. And this one, it's like a ball inside of a cube, which I don't think I'd be able to print this on any of my printers.
We like these examples because it is something that's nearly impossible with any other technology. So it demonstrates the capabilities of our machine really well.
If you don't have the space or really the need for an SLS 3D printer, don't worry. Getting started with SLS printing has never been easier with today's sponsor, JLC 3DP. With their instant quoting engine, you can upload a part, and within seconds you can see how much it would cost to have them manufacture it and ship it to you. In this case, if I wanted to have a Benchy printed, it would only cost about $2 to have it made out of resin, or about $5 to have it made out of SLS nylon. And you can even make large parts, so this part is over 1 kilogram, and it would only cost about $120. Over here we have a part that's over 2 kilograms, and that would be about $343. But let's see what it would cost out of SLA nylon, because that tends to be the most affordable process. Only about $53 for a part that's 1.5 kilograms, so that's quite affordable. Often I'll upload 20 different versions of a part just to see how I can make it more affordable. My viewers can get $60 in coupons by clicking the link in the video description, so it's just a really fun and easy way to get started with different 3D printing processes that you might not have access to with your current equipment. You can even have it made out of more exotic materials like metal. In this case we've got stainless steel. So a stainless steel Benchy would only be about $30. You can do FDM, but I know most of you already have FDM printers, but in any case you can get a Benchy made for under $5. Oh, PLA is even cheaper at about $2. PACF, carbon fiber nylon, you can get that made for a little over $5. And they have fast shipping options. There's a little bit slower options that'll be cheaper, but you can also increase your order size, and that helps reduce the cost of shipping per unit. So if I wanted to have 100 Benchies made, it'd be about $76 in shipping. In any case, you've got a bunch of different shipping options, lots of different colors and materials, so it's something that I think is worth checking out if you need to have parts made. And if you want to upgrade to CNC machined parts, you can upload your parts into this portal and get things made out of 7075 aluminum, which is a very high strength aluminum alloy. You can do copper and brass. So if you want to support a company that supports my channel, head over to JLC 3DP and check them out. And with that, let's get back to the Micronics interview.
Was there a moment in time where you were working on a project and you were like, you know what, now's the time for me to spend thousands of hours developing and building my own SLS machine?
So I started this whole journey when I was in robotics team and I was trying to make parts. But the machine shop in the university would just be closed all the time. They wouldn't be open on weekends. So I decided, hey, I'm going to build my own CNC machine and have it in my bedroom. And then flinging chips in my bed, and I was like, hey, this is terrible. And then I wanted to get into 3D printing, and then there was only FDM and SLA available at the time. So I was like, hey, where's SLS? Looked at it. Hey, $20,000. I don't have that. So I'm like, screw it. I'm going to do it myself.
Henry, you got to get on cam for this. This is your baby, man.
Okay, all right, hand him the mic. I mean, this thing looks insane and very customized. So what can you tell me about this machine, Henry?
So this used to be my bedroom. Got sick of sending parts out to machine shops, so I decided gonna have a CNC of my own.
Yeah.
Looked at the price of tarmac, couldn't afford it, so I just built everything from scratch. This is built just using off-the-shelf industrial control components. There's no schematic for it, it's all in my head. So right now we outsource some of the machine parts, but a lot of times they come back, you want to change some things. This is what allows us to make those changes.
And also, like, if you have a new design that's
Yep.
simple enough, you can just do that real
Actually,
quick.
on some of the older machines, all the parts are just machined on here.
Is there any manual control of this, or do you just have to like control
Well, you
it?
can jog it around using the hand wheel jog.
You know, I taught a machine shop class for a while, and one of the most labor-intensive
Cranking up
parts
the
is
the table on the bridge board.
you end up with this gigantic crank down here, and it's like you're in some kind of dystopian future where the human has to power the machine, and it's a lot of work. But this jogging wheel would be really nice, and I like how it shakes the whole building a little bit. Do your neighbors ever complain? It's like, stop running the CNC machine.
I actually used to live on the 4th floor.
Okay.
It was shaking around the floor too much, so I took it apart, 2 a.m., dragged it down to the 1st floor, moved the apartment, until we moved it here.
All right, this machine, I haven't quite seen one like this. It looks like it has a bunch of dust in it.
So that's a water jet. We use them to do like really quick sheet metal prototyping work. So for example, we recently changed the design of our recoater. We are able to turn it around quickly in-house using a water jet.
What are the advantages of using a water jet versus like a laser cutter or a 3D
It's
printer?
cheaper.
Oh, it's less expensive?
Well, the machine is cheaper.
Okay. Yeah, because having a laser powerful enough to do metal is a lot of work. You've got a nice little machine here. What is this?
That's just a laser for cutting plastic.
Okay, can I open it?
Sure.
All right. Smells good. This is like a sandblasting cabinet.
Yeah, so this is what we use to post-process our SLS prints. You can brush it off with hand like pretty easily, but to get a perfect surface finish, we usually do a glass bead media blasting. It's really quick and makes it a really nice finish. Harbor Freight bandsaw.
Okay, Harbor Freight. The finest.
The finest of just barely works and does the
Yep.
job.
And they've got a warranty, I hear. So if anything breaks, you can just go back and get a new one. Then a plotter too.
Yep, for
Plotter.
cutting some vinyl stickers and a laser engraver.
And then last thing is probably the most familiar to viewers of my channel. We've got a good old Cheedy X-Max 3 and a Voron 2.4.
So we use the FDM printers primarily for the large parts that wouldn't fit on our SLS printers, such as the tools we use for post-processing the prints.
Okay, so like those buckets that I saw earlier that
Yep.
you use to clean your parts out.
So we use these to prototype those, and then in the future we will move the injection molding for those.
Yeah, but I guess you could also make those kind of tools on your SLS printers, but it's kind of like a chicken and the egg problem. Like you can't build a large enough post-processing
Yep.
tool to build a larger, so you got to start somewhere to get big parts, and this seems to be a machine that's capable of that. So this is a 350 by 350.
Yep, Wall 2.4.
Okay. And if you had to pick a favorite machine in your shop, other than your new SLS printer, what would that be? Like if you had to throw all these in the trash except for one.
My CNC, it's what started it all.
Yeah.
So Micronics is actually launching their Kickstarter soon. It should be within the next week this will go live. And they've got a stated goal of $100,000. I think they're going to blow through that. I'm not sure exactly what their desktop SLS machines are going to cost, but I think they're easily going to sell hundreds of these just based on the value proposition alone. If there's anything that I learned from my time visiting Micronics is that these guys are hardcore engineers. They're in it for the right reasons, and they have a great product already, and it's just a matter of ramping that up and getting that to mass production. Now, that is a big challenge in and of itself, and there's always risks with backing Kickstarters. But if you like what you've seen today with our behind-the-scenes look at Micronics, and you've got an extra pile of money lying around that you'd like to see transformed into a SLS printer, then maybe backing this Kickstarter could be the right choice for you. The rest of this interview is going to be more of a sit-down style interview with Henry and Luke, and I think it really gives you a lot of insight into what motivates Henry and, what's going on with Luke when he's on camera. So there's a lot of good stuff left in the video, but I just wanted to let you know it's not going to be the same as me walking around looking at everything.
but it's interesting content nonetheless. So watch to the end and you'll find some interesting tidbits out about the Henry-Luke dynamic. And if you want to support this channel, make sure to check out the links in the description below. That'll take you to my Patreon, and I'll put a couple affiliate links down there as well. All right, so let's get back to the video. Why would you decide to do an SLS machine rather than something like an FDM printer or a CNC machine?
Well, we wanted to find a space where we can differentiate ourselves from our competitors. If you're looking at like a CNC machine, there are plenty of desktop routers available right now. Look at FDM printers, you got like 1,000 end-of-free knockoffs. So we looked at the different manufacturing technologies, and SLS is the one that stood out to us where there's like a huge market gap segment in the professional/prosumer market where it's just not filled. So that's where we decided, hey, we're gonna give that a shot.
What do you hate about FDM and how is SLS any better?
Well, FDM and SLS, they aren't replacement technologies for each other. They all have their own place. The thing with SLS is that it just gets things done. A lot of times you just need to connect two things together and don't want to worry about how it's going to get printed or what direction the load is going to be in. And with SLS, what you can do is just make a thing that has the right geometry, throw it at the printer, and go home. And then when you're doing prototyping, nothing ever fits on the first try. With SLS, you are able to easily drill into it, machine it, cut it down, whatever you like. Unlike an FDM part where you would just split it along the layer lines and have to reprint.
Yeah, I guess that is a major difference. So with FDM, you're constantly like, okay, what orientation am I printing this in? How do I design it so there's no overhang angles? And even when you just grab something off of Thingiverse, you have to think about how do I orient this? But what you're saying is SLS, you can just throw everything in the build volume and press go.
Yeah, and come back tomorrow and all your parts are done. Right now, SLS technology is expensive, it's messy, it's inaccessible. I mean, we have FDM with SLA, SLS patent, they all expired 10 years ago, but right now we only have two that are like readily available and democratized. We want to bring the third one into the marketplace.
What does a typical customer look like to you? I mean, you're designing these for industrial clients or like people to have an at-home machine, or?
It's a mix. So we have industrial clients who already own the big 3D systems machines. The problem with those machines is that it's inefficient to run jobs quickly. So sometimes you just need a part that's robust, but you want it done quickly. With a big machine, there's a lot of powdering to fill up, and there's a long cooldown time. So if you have like a big industrial machine, you're looking at a lead time of 1 to 2 days. Right? That's my experience when I was working at like a big company with SLS printers. With our machine, because the build volume is relatively small, you can just start a print and have it cool down within 45 minutes if it's thin. That allows you to cut down your printing and iteration time from a day or two to 1 day.
Okay, and yeah, I have two follow-ups to that. Like, I've noticed that with my FDM printers, usually I'll send the print job to the smallest printer that the job will fit onto, because I have some really big printers, but you have to heat that whole heated bed up, and if anything goes wrong, it's much more complicated to fix. So it totally makes sense to have a smaller form factor machine. But the other thing is I just realized where your company's name comes from. Is it micronics because you're making a small, like micro thing?
Yeah, kind of. We're just bringing big technologies that used to take up a whole room, and we're shrinking it down to a desktop scale.
Okay. I mostly work with FDM printers, and one of the most important metrics for output for those machines is cubic millimeters per second in terms of like how much plastic you can actually extrude out of the nozzle. Do you have a similar measurement to describe how fast these machines can go?
So our fusion rate is about 15 cubic millimeters per second for nylon. But the great thing is you maintain all the details while printing at those speeds, so you don't lose any strength, you don't lose any surface details.
And do you have like print profiles? So you have like a slower one that's more detailed and like a faster one that's like coarser? Or is it all just like the same speed all the time?
Well, it's all the same, but you can change layer heights. So with larger layer heights, you get coarser finishes. But usually we just print at 0.11 millimeters, and that covers most of the cases.
0.11, okay. Yeah, that's a little bit, that's like finer than what you usually run on an FDM printer, about half the size. So
it's about 2 particle diameters.
Okay, 0.11 millimeters.
Yeah.
Okay, yeah. How much does end user interface play a role in the work that you're doing? Because I've noticed that you're trying to like innovate on the slicer side as well as the making the user experience for post-processing your parts as seamless as possible. Am I wrong in thinking that that's motivated just from a user interface perspective or like a user experience?
Well, we're lazy.
Ah, okay.
So when we were first building our SLS machine, it's more just about getting things done. But then as we are testing it every day and using the machines every day, we realize, hey, I hate doing this because this is clunky. So every little pain point that we discovered, hey, I want a handle here instead of here, we can just quickly change that. And eventually through these quick iterations, we are able to just, fine tune our user experience into what would, allow us to do things quickly with the least amount of effort.
Making your own life easier also makes your customers' lives easier, so it's a win-win there. Luke's off camera right now, but I have a question for him. Can you roll over here? So Luke, you've been doing a great job on camera for your guys' YouTube channel.
Flattering.
So I have to ask, do you have any advice for me to improve my screen presence a little bit?
What Henry always tells me is bring the energy up.
Keep your hands out of the pocket.
That's why I talk like this.
Yeah.
It's
Like
not
this?
always clear how to do that, but yeah, if it's just like that, bring in energy and
Okay.
It's always dulled by the camera, so you got it.
That's true. All right. Well, thanks for talking with me today, guys. It's been a pleasure, seeing your operation, and I hope to see you guys doing more great stuff and making a success out of this company.